We'll proceed in 3D parameterization, Jacobian. 3D parameterization that is in discussion. Very complex and very useful. So, why it is useful? Because we are climbing the step 1D Jacobian dx x equal to any function g over v, then dx equal to dx by du into du. Two-dimensional Jacobian dx comma y dx dy dx dy, that is dx dy is differential in xy plane, dxy plane, dxy plane. If it is dxy plane, dx comma y by du comma v, this is Jacobian. Means dx dy is nothing but dx comma y is nothing but dx comma y by du comma v into du comma v. Numerator du comma v is du dv. This extra dx comma y by du comma v is Jacobian. What is the rate of, what is the change that is seen in the area? What is the area, mapped area? If it is UV plane and there is a rectangle over it and there is a XY plane, there is a mapped rectangle here constitute to some area. If there is a unit change in this rectangle, how many unit change it brings in the mapped rectangle? U plane, UV plane, XY plane. Mapping happens through a function x equal to g u comma v, y equal to h u comma v. If that is the if that is the truth, then dx comma y by du comma v, dx comma y by du comma v. One unit change in the rectangle in UV plane brings how many unit change in the mapped area in xy plane, dx comma y by du comma v. So, if that is the scenario, then it is 2D Jacobian. What is 3D Jacobian? What is 3D? If I say I have a cubical region, if I say I have a cubical region and then I have fx, y, z, small f in bracket x comma y comma z, brace close, fx, y, z, dx, dy, dz, what it is? What it is? Okay, fxy, dx, dy and region on xy plane, what it is? It is calculation of volume. Because I know fxy is nothing but z. If it is xy plane, then fxy is vertical, z. I know that much. So if that is z, fxy, z integration along xy plane will give the z is nothing but a surface. This is xy plane. I take any x comma y within a region. I have to pick x comma y within a region that is specified in the integral. If I see the integral calculus, there I mean specified in the limit, there is a limit, there is an integrand, and there is differential. So in the limit is along the xy plane a region, a two-dimensional region. I have to pick x comma y only in this region. So integration over a region in xy plane, if I pick any x comma y there, then there is a z value for each x comma y. If I connect all the z value, it becomes a surface. That is an idea. If there is a x-axis and there is fx, function over x-axis, every x has a vertical point. If I connect all the point, it becomes a line. If it is xy plane, if I connect all the point, it becomes a surface. If it is x, y, z cube, independent component is x-axis, independent component is xy plane. Now independent component is x, y, z cube. So fx dx calculates the area, fxy dx dy calculates the volume. What about fxyz dx dy dz? Typically fxyz is called density function. I really have a queue. Okay, it is a queue, and it is very useful to me. I mean, it has a voice, and I use this voice for soldering purpose to hold something. Okay, so this is a heavy cube. So this is a cube. This is a cube. Typically, this is a cube. I mean, cube means don't consider it as a where width, height, and length, width, height are same. That is typically a cube. You can rectanguloid, cuboid, rectanguloid, whatever it is. So this is a cubical shape. If this is a cube and this is independent component, okay, hook, XYZ plane gone there. Okay, if I have xy plane and then z is vertical, I consider, then xy plane and z, if I all point, if I connect, it becomes a surface xyz. Now instead, this is, what is this? This is x independent, x axis is independent, y axis. No, this is independent xy plane. Xy plane independent. This is xy plane independent. This is xyz cube, independent xyz cube. X-axis independent, x-axis dependent in function over x, fx. Independent xy plane, function over it is fxy z. Independent fxyz cube and function over it is fxyz. That is called density. Where you will go, x axis, y axis, z axis, all triple you consider, then where fourth axis will go? So people, they generally they consider as density. Density means if this is a cubical shape and it has from this side x axis, y axis, or from my side x axis and then y axis and then above z axis. This is single independent component at x, y, z cube. Then dependent is density function. At what place inside the cube, what is the density? That is in variation with x comma y comma z. So I can represent any point in the cube as x comma y comma z comma d. Okay, in the cube or wherever you want. So if every point in the cube x comma y comma z is it maps to a new value. If there is a function fxyz, f braces small f braces x comma y comma z brace close. If this function where Python function where you give any unique x comma y comma z and it returns you one numeric value, that numeric value is density. If you connect all the density, so x, y, z would be in a cubical region. You remember xy. If I say fxy dx dy in a region on xy plane, it calculates volume. If I have fxyz dx dy dz in a cubical region, x, y, z, triple integration in a cubical region, then it gives the net weight because fx, y, z is kg per meter cube. Dx, dy, dz, meter cube gone, then weight. So if it is a density function fx, y, z, dx, dy, dz is a density function, then then this full integration gives the net weight. I want to calculate net weight of this. Go and weigh on a weighing machine. You will get the net weight. No. I don't want like that because I want through calculus. I want through algebra. Okay, you want through calculus. What you want through algebra? Okay, then what what is more in you? This volume, the density of this volume is not same. What do you mean by it is not same? Somewhere there is air, somewhere there is a voice, somewhere there is air, somewhere there is something else, and all along inside the cube density is not same. Then what is density? Density is function over x comma y comma z. You place x comma y comma z value, it will give you what is density at that point. There is a function. Now calculate the weight. Then fx y z dx dy dz and calculate over the volume. Calculate over the cubical region. That will be full this region. Then it will give you a weight. Like 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 x square y plus 3xyz. This is density function x square y plus 3xyz dx dy dz. X is from 1 to 2, x into y is from 0 to 2, z is from 0 to 1. Now integrate, impossible. I cannot integrate. How you cannot integrate? Try with z first. Then x square y become x square y z, considering x square y as constant. And then 3xyz will become 3xy z square by 2. Now z is 0 to 2. Place it. Now it will become x square y with some numeric value plus x into y some numeric value. Now integrate. Okay, integrate with what? Integrate with dy because x value is anyway outside. Integrate with dy and again the integration limit is in x into y. I cannot do. The limit is x equal to 0 to 1, 0 to 1 to 2, x into y is 0 to 2, z equal to 0 to 1, x into y. You should have given me y equal to something. What is x to y? If x is 0 to 2, x into y is x into y is x is 1 to 2, x into y is 0 to 2. Okay, if x is, now you can manipulate, x is 1 and x into y is 0, then y is 0. If x into y equal to 2 and x is 2, then y is 1. So y will be 0 to 1, something like that. But at the first place, it looks like a horrible, right? Means x into y, if x into y, someone needs to take the limit, it looks like horrific. I cannot do it. You do it. Then someone would think about parametering. So what we have now? We have a density. Now, if I have, now I'll proceed further what I was talking about. So if I have x, y, z point, each x, y, z point would map into a density. Each x, y, z point would map into density. Like a 3D, each x, y point would map into a z value. Each x, y point would map into, if you connect all the z value, it makes a surface. Like that, each xyz point would map into one density. Each xyz point would map into density. If you calculate all the density, it will become a, if you calculate all the density, it will become a volume. It will become a volume. That volume, if you integrate along x, y, z cubical, not plane, then it will give you the weight. Okay, so that is the concept. Now if that is true, then if xyz point maps to a density, and if I connect all the density is not a coordinate, it is understandable. This is how the machine learning would proceed. Up to 3 layer only you can map in xyz, beyond that you cannot do. Now you have to imagine, think. Density function means everywhere density is different. Somewhere it is heavy, somewhere it is lightweight, somewhere it is very heavy, like that. Like inside it, the density every point is different. So now it is a kind of xyz, each point mapped into a density. And if I draw something like all connecting all density, it will make a cube. cubical region. Now, now I am saying that I cannot calculate integration of x square y plus 3xyz dx dy dz where z is 0 to 1, x into y is 0 to 2, x equal to 1 to 2. I cannot do. Let's do integration by substitution. Let's try parameterization. What is parameterization? I have density that is function over xyz. So density thinking is xyz is independent. Now xyz will be function over another coordinate, that is UVW. So UVW is one cubical region, and XYZ is another cubical region. On XYZ there is something called density. So density is dependent upon XYZ. XYZ is dependent upon UVW. Now what is x? X equal to a function over UVW. Y is function over UVW, and Z is function over UVW. X equal to G UVW, Y equal to H UVW, Z equal to T UVW. Now the idea is, now we were calculating fxyz dx dy dz. Dx dy dz nothing but dx comma y comma z. Small d braces x comma y comma z brace close. Dxyz 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 is nothing but dxyz by duvw into duvw as per multiplication. duvw in numerator is du, dv, dw. dxyz by duvw is Jacobian. That is extra thing that is coming. It is like prize money. You converted dx, dy, dz into du, dv, dw. This is the extra you have to append. So dx, dy, dz has become dxyz, d braces, small d braces, x comma y comma z braces close by d u comma v comma w into du, dv, dw. This is called Jacobian. That extra you have to multiply to convert du, dx, dy, dz into du, dv, dw. We also invented this, but later I came to know that it is already available. But the proof is ours because this is the way we invented. So now the way I am saying, this is our way. Everyone would not consider this way. So now what is dxyz by duvw? If duvw is a cube, if it is 3D, it not necessarily it will be cube. It can be a sphere, it can be a cylinder. But for simplicity, consider there is a cube. Now this is UVW cubical region, not plane, cubical region. There is a cube here. Now this is XYZ coordinate system. This is UVW coordinate system. This is XYZ coordinate system. There is a cube I have taken here. This cube is mapped into some 3D shape on XYZ. What is that shape is dependent upon these three functions: x equal to g u comma v comma w, y equal to h u comma v comma w, and z equal to t u comma v comma w. If, if that is the case, then UVW coordinate system, if there is a cube, that cube is mapped into x, y, z coordinate system to a some 3D shape. Now, if that is the case, if there is 1 unit of change in this cube, 1 unit means 1 meter cube, 0.1 millimeter cube, whatever is the 1 unit, but it will be cube. So, if there is 1 unit of change, if I had taken one cube here, there is 1 unit of cube change, then how much unit of volume it would change in x, y, z coordinate? If in UVW coordinate, if there is a cube and there is a 1 unit of change in the cube, how, if this cube is mapped into some 3D shape here, how many unit of change it brings in the volume of the mapped 3D shape? dxyz by duvw. By duvw means if there is a 1 unit of change in UVW coordinate of the cube, numerator, how many numerator has a mapped 3D shape, how many unit of change it would bring there. dxyz by dubw. That is 3D Jacobian. Okay, leave everything. I want to calculate volume of a 3D shape. I want to calculate volume of a 3D shape. What is your 3D shape? My 3D shape is a parallelogram. Oop, oop. My 3D shape is a parallelogram. So this is like this and this is a parallelogram. I mean this is this is rectangle, but consider two sides of the parallelogram. Oh, okay. This is a parallelogram. This is a parallelogram. Now consider one more line parallel to this and one more line like this. Now it will make a parallelogram. What is area of the parallelogram? This is A vector, this is B vector. A vector cross B vector is the area of parallelogram. Now consider this is XY plane. Now it is sitting on XY plane and there is a vertical axis also and it makes a 3D shape. What is the volume of 3D shape? Then A cross B is the area of this parallelogram. It will be a vector. Cross, cross, then other vector. Then full volume it will give. No, it will not give you the full volume. It will turn up it to 0 because the area vector cross product is a vector. So if I do cross product of this and this, then it will give me area vector, whose magnitude will be the actual area what we are calculating, area vector. And area vector will have a direction. So if this is the area, then it will have direction like this, k vector. If this is in xy plane, this area vector will have k direction. If you do cross product with the k only, then it will give you 0. So if this is A, this is B, and this is C, then if you want to calculate the volume, then it is C dot product and A cross B. This is called triple scalar product. Okay, so triple scale. This is how we calculate the volume. If I have three vectors and if I want to calculate the volume, then it is C dot A cross B. C vector dot and in braces A cross B. What we are trying to calculate 3D Jacobian. dxyz by duvw. If there is a cube in uvw coordinate system and there is a mapped cube in xyz coordinate system, if there is a unit change in cube in uvw coordinates, how many unit change it brings in xyz z 3D shape as per the function it is mapping? That is under question. Now I have fxyz. So I have a volume, I have a volume, I have a cubical region, and this cubical region I have xyz. Each point xyz is mapping into a density as per the density function, fourth dimension, 4 dimension. Now if I connect all the density function, density point, it makes a volume. Now consider in this volume any point. So like if this is the if this is the cube, then if I take any point inside the cube, what is that point is? X comma y comma z. No, x comma y comma z comma d, where d is function over x y z. X comma y comma z comma f y z. Now if I say 2 comma 3 comma 4, 2 comma 3 comma 4 comma 5, 5 is the density at that point. Now that is the fourth dimension, four dimension vector. What is position vector there? That is xi plus yj plus zk plus d plus d gamma. Gamma is my fourth coordinate, d gamma. D is the density, d gamma. Okay. Now if this is if xyz is the independent component and it is a cubical region, and if I connect all the density point, it is another cubical region, then the point, the if I take any point in this density cubical region is x comma y comma z comma d. If I take a position vector in this cubical region that connects from the origin, Then now you imagine 4D, okay? Then 4D means it has three sides. One is x axis and density axis. Consider density axis as fourth axis. X axis and density axis is x density plane, y density plane, z density plane. XZ plane you would have heard, YZ plane you would have heard, X density plane. So consider, oh, okay, it is very heavy. Okay, so if this is X axis, then what is X density plane? On X axis, density is different at different moment. It is not Z. Y density plane, Z density plane. Consider this is the plane, X density plane. Now, if I have a position vector P that is xi plus yj plus zk plus d gamma, then what is dp by dx, dp by dy, dp by dz? I won't say dp by d gamma because gamma, dp by dd, because d is a dependent component. How much this position vector would change along the x-axis dp by dx. Dp by dx, if you see, it will be I plus d by dx gamma. J and k will go away. I plus xi. So I plus d density by dx gamma. dp by dx is a vector. I plus gamma is a vector in x density plane. dp by dy is j plus d by dy gamma. dp by dz is k plus dd by dz gamma. Now there are three vectors we are getting: dp by dx, dp by dy, dp by dz. Now all three vectors, one vector is in x density plane, one is in x y density plane, one is in z density plane. Density is one separate axis. If that is the case, then dp by dx is the area, velocity area vector. This is what I would say, because one differentiation is there. dp by dx cross dp by dy is the velocity area vector in density term. dp by dx cross dp by dy dot product with dp by dz is the volume velocity. So dp by dx cross dp by dy in braces dot dp by dz is nothing but d volume in the density cube by dxyz. The dense difference in the volume that is constructed by the density function by dxyz means if there is a cube in xyz plane, in xyz independent cubical region, if there is a unit, and there are two cubical regions, one is xyz and one is that is formed by the density. If there is a unit change in, if xyz is a coordinate system, if I take a cubical region in the coordinate system, this cubical region would map into some 3D shape in the density region, not the cubical region, as per the function fxyz. Here fxyz in our example is x square y plus 3xyz. So if xyz is an independent coordinate system, xyz is a cubical region. If I take in that coordinate system, if fxyz is a function, that function maps into a density area sum to some 3D shape. I won't say exact cube, but some 3D shape. This is better word. Some 3D shape. If there is one unit of change in this cube in xyz, called how much unit mapped 3D, how much unit change it sees there, that is dp by dx cross dp by dy dot dp by dz. dp is the volume, it is the volume that is mapped volume in density area by dxyz, that is the cube. So if I have xyz cube, xyz coordinate system, and that coordinate system is mapped into density region, and if I take a cube in this coordinate system, if I make unit change in this cube, then how many unit change that is seen where this cube is mapped into the density volume region, how many unit is say change is seen, that is dp by dx cross dp by dy dot dp by dz. That is nothing but, what is the dp by dxyz. Now here I have a UVW coordinate system and XYZ coordinate system. Here here we were taking one cube in XYZ coordinate and it was mapped into density. Now I take a cube in UVW and it is mapped into XYZ coordinate system. If there is a unit change here, how many unit change I can see in the 3D shape in XYZ coordinate system? dxyz by duvw, dp by dxyz by dp by dx cross dp by dy dot product with dp by dz. Now here it is dxyz by duvw. If xyz I consider as a position vector xi plus yj plus zk, then dp by du cross dp by dv and then dot dp by dw. So this is the Jacobian. So dx comma y comma z by du comma v comma w is nothing but, if I x comma y comma z, it is a volume, it is a 3D surface. UVW coordinate system, I have taken a cube. Cube is mapped into XYZ coordinate system and constitute a 3D shape. As per the function x equal to GUVW, y equal to HUVW, and z equal to TUVW. So cube in UVW axis, it constitutes to a 3D shape in XYZ. dxyz by duvw, if there is a unit change in cube, that is in UVW coordinate system, how many unit change it will make in 3D shape, that is mapped from cube in UVW to XYZ coordinate system. If I take in 3D shape in XYZ coordinate system any point as p position vector, then dp by du cross dp by dv and then dot product with dp by dz. Okay, that will, if you settle it down, dp by du is nothing but dx by du I plus dy by du j plus dz by du k cross product with dp by cross product with dx by dv I plus dy by dv j plus dz by dv k dot product with w dot product with dp by dw, that is nothing but dx by dwi plus dy by dwj plus dz by dwk. If you settle it down in a matrix, it will come as a determinant of a matrix where top row is dx by dui plus dy by duj plus dz by duk. Similarly, dx by dv and then bottom row is dx by dw. Fill it. Or you can take, since we are Jacobian is absolute value of this, I can take transpose of this. So dx by dui plus dx by dvj plus dx by dwk. Next row dy by dui d plus dy by dvj plus dy by dwk. dz by dui plus dz by dvj plus dz by dwk. Okay, calculate the determinant, take absolute value, not the sign, minus sign or this sign, that sign. Okay, that is dxy by duv. Now someone can settle it, this integration, that is x is 1 to 2, x into y is 0 to 2 and z is 0 to 1, and the integrand is x square y plus 3xyz dx dy dz. Now if I calculate the Jacobian, then dx, now how I can take the parameterization. That is the idea. You see, x, y is a limit 0 to 2. X, y is jumping. X square, now integrand is x square y, x into x y. And there 3 x y z, 3 into x y into z, or x y into 3z. So x y I can take as v, x I can take as u, and 3z I can take as w. Okay, so integrand would become now x square y u into v plus 3 3z will become w and xy become vw u into v plus v into w. V if I take outside, then u plus w, v into u plus w. Now dx dy dz now convert into now dx by dui plus dx by dvj plus dx by dz. Now calculate this matrix. So dx by du, since x equal to u, so dx by du will be 1, rest will be 0. Now x into y equal to v, x into y equal to v. Then what about y? Y equal to v by x. X is u, y equal to v by u. Now dy by du would be minus minus v by u square. I believe so. Minus something like this. V by u, 1 by u, if you calculate differentiate, it will be log. I'm sorry. V by u. Yeah, v by u. If you differentiate y equal to v by u, then 1 by differentiation of, differentiation of 1 by u would be minus 1 by u square. So minus v by u square, and then dy by dv, 1 by u, next is 0. Here z will be 0 0, and w z equal 3z equal to w. So z is equal to w by 3, at the end 1 by 3. Whatever it comes, calculate it. If I believe top is 100, and next is minus v by u square, and then 1 by u, and then 0. 1 is 0 0, 1 by 3. So 1 by 3, take it and then multiply the section. So it will be this multiplication, 1 into v, 1 into 1 by u. So it will be 1 by u, 1 by 3u, 1 by 3u. So 1 by 3u, and then here it is v, here it is uv plus wv into 1 by 3u. 3u is denominator, du dv dw. Now limit is x is 1 to 2, it is u is 1 to 2, x equal to u. X into y is 0 to 2, then it v is 0 to 2, z is 0 to 1, z equal to z, 3z equal to w. So it is 0 to 3 now. So u is 1 to 2, v is 0 to 2, and w is 0 to 3. And here u into v plus v into w into 1 by 3 u. 1 by 3 I can keep outside, and 1 by u. If I settle it down, it will become v plus v into w by u. Now do the integration. It is far easy because all limits are in numeric now. There is no x into y or something like that. So someone can try integration with the w first. Whatever comes, then with the v, then with the u. So in the limit, that fear of x into y went away. So this is 3D Jacobian. So we will talk more on it with example by example. So parameterization, where we have d of surface area by d of surface area in two different coordinate systems, d of volume to d of volume in two different coordinate systems. This is the most pioneer thing in calculus. It will be highly useful in resolving where we have so many features in machine learning and then doing some kind of calculus over it. Each feature is one dimension, 1000 dimension, 10,000 dimension. So there it would be helpful. So we will see more on it.